collecting like terms, okay, in this video lesson. So as to simplify, giving your answers in the form a plus bi, where a belongs to the set of real numbers and b belongs to the set of real numbers. Okay, so we're looking at your complex numbers here, where I is the square root of minus 1, if you're wondering, and I squared is denoted as minus 1. Okay, so this is looking here at complex numbers, but this is just here like a little recap here, obviously collecting like terms. So the idea here, guys, is that we collect our real parts together, so our numbers or constant terms, and then collect the terms in I together. So part A, we got 5 plus 2i plus 8 plus 9i. So we do 5 plus 8 makes 13, then plus 2i plus another 9i makes plus 11i. Okay, so 13 plus 11i. Part B, okay, we're going to do something similar. 4 plus 10i plus 1 minus 8i. So 4 plus 1 makes 5. We got positive or plus 10i, and we're adding on a negative 8i, so that becomes a subtraction. So it's 10i minus 8i makes plus 2i. Okay, so if you're adding a negative, just to be clear, if you're adding a negative 8i, it's same as subtracting 8i, okay, just to be clear. Okay, so we do 10i take away another 8i to get 2 lots of I, or i's. Part E, okay, so we're not actually, oh, sorry, part C, sorry, I apologize. 7 plus 6i plus minus 3 minus 5i. So 7 plus minus 3 is 7 minus 3, which is 4. Then we got plus 6i plus minus 5i becomes minus 5i, so it becomes plus 1i or plus I. Next up, okay, so again, adding the real parts together, so a half plus a third I, plus 5 halves plus 5 thirds I. A half plus 5 halves makes 6 halves, but 6 halves means 6 divided by 2, which is just 3. Then I've got a third I plus another 5 thirds I, that makes plus or positive 6 thirds I, which is just 2i. Okay, so remember, when we're adding fractions, we must have a common denominator. Okay, so what I've done here is just add my numerators. Okay, so because I have got a common here, I just do 1 plus 5 makes 6. So I get 6 over 2, or 6 halves, which is just 3. And then similarly, I did a third I plus 5 thirds I makes 6 thirds, okay, or 6 lots of thirds I, and 6 divided by 3 is just 2, so we get 2i. Okay, part E, 20 plus 12i minus 11 plus 3i, or 20 minus 11 makes 9, and plus 12i minus plus 3i is plus 12 minus 3 makes plus 9, so 9 plus 9i. Okay, don't ever hear, or sorry, I shouldn't say don't ever be here, don't bother factorizing it, because it wants it in this format exactly. Okay, so bear that in mind. Okay, so don't worry about having to factorize that. Okay, so 9 lots of 1 plus I. Next up, part F, 2 minus I minus 5 plus 3i. So 2 minus minus 5 is 2 plus 5, which is 7. Then I've got minus I, and I'm subtracting another positive 3i, makes minus 4i. Okay, part G, minus 4 minus 6i minus 8 minus 8i. So again, collecting the real parts. So minus 4 minus 8 becomes minus 4 plus 8, which is going to be just positive 4. Then I've got minus 6i, subtract negative 8i. So minus 6 minus 8 is minus 6 plus 8, which makes positive 2, and then tag on the I. So 4 plus 2i. Okay, next up, we've got 3 root 2 plus I minus root 2 minus I. So 3 lots of root 2, yes, subtract 1 lot of root 2. Okay, minus 1 lot, yeah, it becomes 2 root 2. Then I've got plus I, and I'm subtracting negative I. So be careful. A lot of students here would have actually put 0 there, but you've got I subtract negative I. So you're doing I take away minus I, which is I plus I, which is 2i. Okay, and then part I, we got minus 2 minus 7i plus 1 plus 3i minus in brackets minus 12 plus I. So collecting my real parts, get all the constant terms, minus 2 plus 1 is minus 1. Then subtracting negative 12 becomes minus 1 plus 12, which is positive 11 or plus 11. Then I've got minus 7i plus another 3i is minus 4i plus another I, so 1i makes minus 3i. So 11 minus, or 11 subtract, 11 take away 3i. And then finally, part J, guys, we're almost there. Okay, so again, collecting my number parts, we got 18 minus 15 makes 3. Minus 3 obviously goes to 0, so we got 0 in the real parts, okay. Then we got 5i minus 2i becomes 5i plus 2i, so we got plus 7i, but then we're subtracting positive 7i, so that is just also going to go to 0, so we got 0 plus 7i minus 7i, which is literally 0 plus 0i, which is just equal to 0, okay? So there, yes, so literally the answer for that one, yeah, is literally 0, okay? They will accept, of course, 0 plus 0i, but obviously we know that obviously 0i is just going to be 0, so you literally have 0 plus 0, which is equal to 0. So the answer for part J is literally 0, okay? So when you collect your real parts, we did 18 subtract 15, then we subtracted another 3 for the real parts, which gave us 0. Then we had 5i subtract negative 2i, and then we minus plus 7i or minus 7i. So 5i minus 2i is 7i. 7i minus 7i is equal to 0. And that is collecting like terms in the further pure maths case section for complex numbers, okay, the core pure section, okay, or core pure 1, okay, or FP1, yeah, further maths pure 1, okay, looking at the complex numbers chapter for collecting like terms in the numbers section, okay. So we collect the real parts together and then collect the imaginary parts and leave our answer in the form or format a plus bi, or a plus or minus bi, or plus or minus a plus or minus bi, okay, where a and b are real numbers, okay, so real numbers.